biodiversity seems to be in the tropics. Well, that seems to be, we know that. Rainforests and coral reefs are threatened on a global scale, and if you know, and this goes back to now that you know about what makes these guys work and live. When politicians ask me, well, what can we do? Well, you know, this seems like a natural cycle, and yes, we're in a natural cycle. So anybody says anything to you, yes, well, global warming, it's a natural thing. Yeah, it's true. We are in a natural cycle, but you can't tell me what we added into the system in the last 100 years has not changed the chemistry. Now, I'll ask all you guys, what happened to trees in the last 100 years? Amazon, northern rainforest, redwoods, gone. So you got 2 vacuum cleaners, 2 Eureka vacuum cleaners, plankton and trees. We know what happened to trees. They're sucking the stuff up. They bury carbon in their trunks, and the older the age of the tree, that many years of carbon they're storing, the greenhouse gas that traps heat, right? So what's happening to the oceans? Massive changes in temperature cause die-offs of plankton. They don't, just like you, when you get a high temperature, you feel sick, you don't really want to eat. You don't want to go to a restaurant and eat a 5-course meal. You just want some soup, sit there. You're not going to really do anything. You're not going to be productive. Well, plankton are not productive when they have fevers. They sit there, get sick, and they don't want to really probably eat carbon and take it out of the atmosphere. So they just sit there and they die. Another thing is, if they're not eating and they're being stressed by temperature, they dissolve. And what did I say what happens when you dissolve more? You get more CO2 coming out of the ocean, making it more acidic. Ocean acidification and temperature combined are affecting the way fisheries are thriving today globally. But temperature is 75 years, you'll get the weakening skeletons from pH shifts. Temperature happens immediately. They die right away. pH is a slow death. Oysters, you know, why are the oysters dying? Well, there's a whole cascade of events that are happening with oysters and a lot of the shellfish, mainly because of temperature and susceptibility to infections. But you got a question?
No.
Go for it.
No, I haven't.
I love questions. Yes?
Well, millions of years ago when the dinosaurs roamed the earth, the
65, okay.
the temperature of the atmosphere was actually warmer, right?
Mm-hmm.
And the type of trees that were available were mainly like palm-like trees.
No. There were old-growth, huge trunk-bearing trees. But there's something about that. Yes, it was warmer in the Cretaceous. But guess what? Those organisms that thrive, those coral reefs that thrive, those mangroves that thrived when the dinosaurs were here, they were allowed to thrive for 65 million years at that temperature. Here, in the last 250,000 years, forget about the last 250,000 years, the last 100 years, we've changed global temperatures. There's a thing called evolution. They can adapt. I mean, if we gradually raise the temperature, like happened when the dinosaurs were around, they can start to adapt to it. Their body chemistry can adapt. But if you change it within 50 years and add all this carbon and increase all this temperature right away, ouch, I can't adapt. That's not evolution. Slow, gradual changes and adaptation to increased temperature and ocean acidification. So we've never seen in the record, in the ice core record, in the fossil record, this fast acceleration input of CO2 into the system. Just a little background, troposphere, here's where all the weather happens, here's where the stratosphere is where the UV protection, the ozone layer is, and ozone protects us from UV radiation, and over here is where all the greenhouse gases are segregated into the lower part of the troposphere. And carbon is a heavy gas. It doesn't outgas into the stratosphere so easily. So ozone loss in the stratosphere, troposphere is where the heat-trapping gases are located. It's undeniable, the increase in temperature. Let me just go to some pictures I wanted to show you. Sorry. Well, it didn't show what I wanted it to show. It's not translating it. But this picture here shows the rapid increase in over 100 years of CO2, which is synergistic. You have the same line, graph that I had showed CO2 and temperature accelerating at such a rapid rate. But when you burn carbon, if you burn carbon right now, the carbon that burns in your tablespoon and evaporates and goes into the atmosphere, you will not feel the heat trapping effect to that 1 gram for 100 years. So guess what, guys? We're just feeling, 100 years ago was what year? It's 2011, so it was 1911, correct? So right now, you're feeling the heat trapping effect of what happened in 1911, before 1911. Oh my God. The biggest boom of productivity happened from World War I all the way past World War II. You have any idea the amount of carbon that we released in this last 40 years, 50 years? So it takes 100 years to feel the effects. So these crazy weather anomalies that you see, these intense hurricanes, cyclones, weird climactic events that have been changing weather, are just from the carbon that's regulating the atmosphere from 100 years ago. So we have not even seen the full effect of global climate change, of global warming yet. And in the next 20 years, we predict, and there's a consensus that all us coral reef scientists agree on, that in the next 20 years, they're going to be gone. So in the next 10 to 20 years, you're going to see the massive wipeout of major coral reefs. Florida has 3% left. The Caribbean has about 20% left. The Great Barrier Reef is undergoing, in the last 5 years, a massive extinction of corals. The only area that's left right now, Palau, Philippines, coupled with coastal pollution, runoff, construction activities, and temperature, the only place that seems to have been spared is Southeast Sulawesi in Indonesia, and that's why I keep going back there. And it's only been spared because it's very hard to get to these reef locations, one. And number two, Antarctic surface water is mixing with the Crucio current. It's bringing cool water in Indonesia. So when you get these hot flares of water forming over Indonesia, they're quickly cooled by Antarctic surface water that's brought up from Antarctic. So they've been lucky, but they've been hit more frequently than the past. Yes?
Can they migrate to cooler conditions, cooler climates?
What's the key? Evolution, gradualism, time. It's happening too fast. There have been a lot of crazies out there saying that, oh, don't worry, they're moving up north. Well, yeah, bacteria is moving up north, not significant old growth forests, not significant reefs, mangroves. If it happens slowly, of course that can happen. But we're talking about what we're doing to this system, what we're doing to this planet over weeks, minutes, is just unprecedented for sensitive organisms to survive. Yes?
What is the upspike in 1940?
World War II, industrialization, making metal for
So I was guessing.
Yeah, industry. Yeah, it
But
was
was
massive.
a
lot of burning and smelting.
That significant?
Yeah, and cutting. So you had a combination of cutting forests for hardwoods. You had a combination of smelting and burning of carbon, coal burning. There was a lot of industrialized, as well as burning. So a combination of burning and adding from industry caused that spike to intensify. Then after the war, it sort of calmed down, and then over at the end of the 70s, you had this. Yes?
That's the surface temperature of the water
Mm-hmm.
of the oceans.
Let me get this other graph. Go ahead, I'm listening.
No, I just was wondering, and that's an average taken.
Yeah, let me. I have the other graph I want to show you. Well, I got to do it. So let me just switch it. Let me get it from there and bring it over here, because it's a really good graph that was put together by Hansen from NASA. Just give me 1 second. Safely remove. Let's pull it out. Yeah. So what you're gonna? I'm gonna show you a